All right, so on F, again, it's the same idea. We're trying to simplify this down to the form b to the n, where n is a natural number. Again, the natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. And that's a meaningful number because it tells us now, it's like a counter, how many factors we have multiplied together. So kind of for the first time here, we have division, right? Really for the first time. That's what this horizontal bar means. It's not just a fractional bar, it's a division bar. So what we're going to do here is simplify as much as possible. Now, take inventory. You have 3 factors in the top, right? Separated by the 2 dots. 2 factors in the bottom, separated by the single dot. What's nice is you can divide out common factors. That's what happens when you simplify something. So again, off to the side, if you have 4 over 6, that can simplify because that's really 2 times 2 over 2 times 3, right? And you can divide out common factors, okay? That's nice. Those do not cancel. I don't know if I mentioned that already in here. Things cancel to give you 0. Things divide out to give you 1. So if your teacher in the past said that the 2's cancel, you know, shame, 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 shame. We're going to learn the new terminology or the correct terminology. Those do what? The 2's here do what? They used to cancel incorrectly. Now they divide out, because things divide out to give you 1, which is the identity element of multiplication. Let's talk about canceling. 2 minus 2. Those cancel to give you 0. Okay? Things cancel to give you 0. Okay? Things divide out to give you 1. Very important. So we can divide out common factors. Now, we can't divide out common terms. Look at this. If I have 2 plus 5, let's say, over 2, do those divide out and give me 5? No, they don't. Has anyone here ever tried that? You're admitting it? Yeah, maybe back when you were younger, or maybe at like a math party when it's time for you to tell a joke. Hey, everybody, you know, right? Yeah, yeah. This does not work. And the reason being is because 2 in the top is not a factor, it is a term. Good. We don't divide out common terms. We can only divide out factors, which means they have to be what multiplied? Multiplied. Very good. So let's come back up here. We have nothing but factors. Does anything divide out straight up right away? Simplify early and often. The 7's do? Look at this. Ooh, that's way too much highlighter. Back it up. How about 9 and 3 squared? Yeah, that's what you said. You're taking inventory, right? You're checking the conditions. Is there water in the pool? Check. Is it full of green algae water? Ugh, I don't want to jump in that even on a dare, you know? 3 squared is 9, so those divide out. Now, when they divide out, don't like obliterate them because I need to be able to see what's underneath there still, okay? But yes, you can do this. I like to make that sound. Boy, that's a fun sound. They divide out. So they're gone because 1 times anything is itself. Now, look at the 7's. 49 is really 7 squared, isn't it? So we've got 7 cubed, 7 to the 5th. I don't want to have to expand those out just to be able to divide them out. So here's what I'm going to do with what's left. I'm going to write 49 as 7 squared, and then I got 7 to the 5th over 7 cubed. Let's go ahead and combine those 7's in the top, shall we? What do we do when we're multiplying and the bases are the same? We add them. So we get 7 to the 7th over 7 to the 3rd. Now we're going to develop the 3rd rule for exponents. When you are dividing, not multiplying, and the bases are the same, what do we do with the exponents? We subtract them. Very good. All right. So 7 minus 3 is what? I'm going to show this step just one time so you know what I'm doing. You don't have to show that step, but it shows the subtraction, and we're left with 7 to the 4th, and that's your final answer. And notice I am working straight down, right? I'm working straight down. Now, here's why it works. Let's come off to the side. More, we do as much work on the side as we do in the project. 7 to the 7th over 7 cubed. That's really 7 times 7 times 7 times 7 times 7 times 7 times 7. All over 7 cubed is 7 times 7 times 7, right? That, when in doubt, expand it out. But man, you need a little bit of time to do that. Now, if there's a 7 factor in the top and a 7 factor in the denominator, they can do what with each other? Divide out. I got you. Yeah, they can divide out. Now, you could do them one at a time, or you could do them in one swipe. Boy, look at that. And now you count up how many are left, because this is 1 times 1 times 1, which is 1, times 7 to the 4th. So that's how we can generate that rule. We develop the rule. Now we can state the rule, and we can use it, especially when we have funky exponents that aren't natural numbers. So let's come back up where we had some rules somewhere. Oh, it was over here. Okay. Let's add this rule. It helps just to write things out in our own handwriting. So this is rule number 1. This is rule number 2. Here's rule number 3. X to the a divided by x to the b is x to the a minus b. And it's important that it's the numerator exponent minus the denominator exponent, because is subtraction commutative? No. Do your worksheet, right? There's the ice falling. Those are the 3 important rules of exponents that you learned back in the day. Maybe when you first learned them, the very first thing that happened was your teacher put up a box that had these 3 rules in them, and then you practiced the rules, right? That's one way to get things done, right? Memorize the rule and then practice the rule. No speeding. Now I'm not going to speed. I don't know. That might work. We didn't do it that way, did we? We explored with our own mathematical machetes, and we came across something, and we saw the pattern for ourselves, and we generalized it, and we discovered the rule, each of them. And now those rules belong to us. No one can take them away. Right? There are rules. She was drawing a heart. I know I feel the same way when it comes to these 3 rules, right? They belong to us. Joy. I love what I call joyful rigor. We're learning some really cool stuff, but we're doing it with joy because we're unicorns. All right. Is that the only way to do the problem? Heck no. Heck no. Okay. Let's look at one other thing here. We're running out of sides, but let's say that I didn't notice that the 9 and 3 squared divided out. Look what I could have done instead. I could have done 9 is 3 squared divided by 3 squared. Now they look the same, so now I know they divide out. But hey, let's use the rule of exponents that we just discovered. That would be 3 to the numerator's exponent minus denominator's exponent. Yes, yes? What's 2 take away 2? 0. Ruh-roh. What is 3 to the 0 power? It's got to be what? It's got to be 1, because what's 9 divided by 9? 1. What's 3 to the 0? It's 1. It's not showing up. Come on. See? It's got to be 1. So if you've ever heard, why is any number to the 0 power 1? Now you know why. It has to be in order to preserve the rules of exponents. Because 3 squared divided by 3 squared is 9 divided by 9. Anything divided by itself is what? 1. And therefore, 3 to the 2th minus 2th power is 3 to the 0th, which has to be 1. What's 5 to the 0th power? 1. What's 10 to the 0th power? What's negative 27 halves quantity to the 0th power? What's negative times 27 halves to the 0th power? Negative 1. Ah, yeah, because it's 1 times negative 1, right? Okay, I got you. It's hard when I like talk about math because you're like, where is he writing that? Is it in the sky? And if so, where does the sky begin? Is it here or is it a little bit higher? Hey, we're done with number 1. We're done with number 1. We're done with number 1. We got 7 minutes left. I know, right? But here's the thing. Now that we know the rules, we can boogie, right? We can fast track boogie. We don't want to go too fast when we're discovering things with our mathematical machete because that could get dangerous and we can miss things. So, oh, here's a joke that's apropos. Here's a joke that's apropos. Apropos is like French for appropriate. 7. When you spell it out, it's like that. It happens to rhyme with my first name. What type of number is 7? Even or odd? Odd. Yet, the number 7, when you spell it out, has even in it. Ah, is that what makes it odd? That certainly makes it peculiar as well, right? Not every odd number is peculiar, but 7 sure is. All right. Here are the properties that we've kind of already developed. Yes, yes? They're just now in one place. This is what your maybe other teacher gave you on day 1 right away. Boom. Here are the rules. Memorize them. Let's try them out. Multiply, base is same, add. Here's an example. Divide, base is same, subtract exponents. There's an example. Anything to the 0th power except 0, because 0 over 0 is not 1, because you got a 0 in the denominator. But anything to the 0 power other than 0 is what? 1, and now we know why. Raise a power to a power, exponentiation becomes multiplication. There's an example. Now here's another one that I don't think we've explicitly stated. If you have multiple factors in a group raised to a power, and we did it with negative 1, it's like raising each one. So if I have like 3x squared y all to the 3rd power, that's like 3x squared y times 3x squared y times 3x squared y. If you put little exponents on everything that doesn't have one, put a 1, now you can distribute the exponent and multiply. That's 3 cubed, x to the 6, y to the 3rd. Okay? And again, it should make sense why. If you just write that out 3 times side by side, you'll be able to collect your like factors. Now, these have to be multiplied. What if I had this, 3 plus x squared to the 3rd power? Could I then distribute the exponent to each of these and call it 3 cubed plus x to the 6? Rhymes with go and starts with hell n. No. Good. Hell no. You know why? Because in this parentheses, these 2 fellas are not factors, they're what? Terms. Terms. But over here, these are all factors. And you remember earlier when I had the Worcestershire sauce? I put all those words together. Exponents, multiplication, factors, multiplication. The rules of exponents only work with factors. Okay, and then the last one, it also works with division. If you have a quotient, which are really factors, you can distribute the exponent to both of them. Okay, so if you had something like this, 3x squared over y cubed, bless you. Oh, never mind. Do your math homework. God, I'm conditioned incorrectly. Let's call that 2, all to the 4th power. This is one giant term, right? With 1, 2, 3, 4 factors. They're factors. They're multiplied. Guess what we could do? We can distribute that 4 to every number. But here's what I would caution you. Make sure you put a little 1 exponent on the things that don't have a 1. Here's why. The first factor becomes 3 to the 1 times 4. It becomes 3 to the 4th. And you know what happens a lot of the times when students don't put the 1 there? They know to multiply, but guess what they do? They do 4 times 3 and they put 12. Oh, that's wrong. Hello, Coach Cologne and Coach Dozier. No? Oh. Have a pep rally in here instead? Yes, let's do it. Everyone bring out the monoceres. You have them with you? Oh, absolutely. Oh, looky here. Looky here. Looky here. Looky here. OMG. Oh, I do. Thank you. I know you can't tell, but right now Terrence is happy. He's so happy. All right. So is this for me? Thank you. Oh, thank you. Oh, and thank you. How about a, oh my gosh. Yeah, oh, so nice. Thank you. Oh yeah, let's go in the hallway. Guys, we're done for the day. Yeah. I'm so sorry. I'm recording right now. Let me go stop the recorder. Hey, that's all good. I feel like a band student jazz running. Yeah.